Good afternoon. My name is Carmen. I'm from Sisimar in Portugal, and I'm going to talk about an example under the motto of the Congress of translating science into action, and in particular how we can apply the ecosystem service approach for better decisions by managers. This is work that is still in progress, and as you can see, there are many authors. This is teamwork. So in this presentation, I'm going to talk about our system of study, which is the Ria Formosa lagoon. Then I will talk about the objectives and the approach we are using in this study. It's a scientific project led by Professor Santos. He's here in the room. And I will briefly present a case study about the dredging in a seagrass area, also in the Ria Formosa lagoon. And I will give you some take-home messages at the end. So the Ria Formosa is located in the most southern point of continental Portugal, and it is a lagoon protected from the ocean by several barrier islands, as you can see in the picture. And the dune system serves as a protection for a vast area of marsh and channels, and it has an average level of 2 meters and an amplitude of the tide of 3 meters. It means that there are amazing areas, vast areas of intertidal. So it covers around 55 kilometers in length, and it supports the pressure of 5 cities with more than 200,000 inhabitants. And because of the high ecological value, it is protected as a natural park, and also with different protection figures in Europe, as the Ramsar site and the network Red Natura 2000. It has a high economical and social importance because it supports activities such as fishing and clam farming, and is also very important for the locals. So about 2,000 hectares of the Ria is covered by coastal vegetation, being the main ones in the intertidal, the Sostra nulti, and also Spartina maritima, which is a salt-marsh plant in the upper intertidal. And we also have in the subtidal, we also have mixed meadows of Simodo cyanodosa and Sostra marina, and also the green algae Caulerpa prolifera. I would like to say that the Ria Formosa is one of the few places in Europe where you can find the 3 species together. So it has really a high value in terms of biodiversity. So as many other places around the globe, the Ria Formosa is under the threat of human activities, and this has the most important impacts in the area. Well, just to say some of them: the inputs of nutrient and organic matter due to untreated sewage, the use of the land of the intertidal area for clam farming, because as you can see in the, I don't know if it is, in here, they put sand on the top of the seagrasses so they can create the beds they need for the clam farming. There are also impacts due to clam and bed digging, due to dredging activities, the boat propellers and anchorage, as well as land reclamation for the construction of ports, marinas, and other coastal works. So in this framework, the RiaValue Project is a scientific project that aims to give an integrated framework for the evaluation in both ecological and economical terms of the ecosystem services that coastal vegetation, including the seagrasses, gives in the area. It also aims to the final aim is to use this information to inform decision makers in the area to make a better job in the decisions. And the final aim is to create this framework to use in a sustainable manner the area for both human activities and the conservation of the seagrasses and other vegetation. So we are working in the project in close relation with decision makers. In fact, one of the co-authors of this presentation is the director of the Natural Park, and we also are in close connection with the citizens And if you want to hear more about this, please don't miss a presentation by Santos tomorrow at 11:30. He will talk about this more social part of the project. So how we are applying the ecosystem service approach. We first identify and quantify the ecological processes and drivers of the ecosystem services. We are doing this based on the amount of information that is already published by many of you. But also we are interested in using parameters and drivers that are important at a local scale. So we are also collecting a lot of data in situ. Once we have identified the ecological process and drivers, we define ecological protection functions, which are basically mathematical expressions that allow us to estimate the ecosystem services based in other more common variables and also depending on the environmental data. Once we have these functions, we create spatially explicit models based on GIS, basically the mapping of the seagrass and other coastal vegetation, and we use it with environmental data to estimate the ecosystem service at the regional scale, at the scale of the whole Ria Formosa lagoon. Once we have these models, we can play a little bit with them and create different scenarios to see how the land use and the different decisions by the coastal managers can change the delivery of the ecosystem services by the seagrasses and the other coastal ecosystems. There are many ecosystem services to focus on. We are focusing at the local level in these three: water purification by seagrass meadows, the fisheries support, because in the area seagrasses act as nursery habitats for many commercial species, and also they are important as recruitment areas of bivalves because they use them for the clam farming. And we also are interested in two global ecosystem services, which are buffering against ocean acidification and blue carbon. I will talk a little bit about the blue carbon. As I said, this is still a work in progress, but we have already a lot of data for the blue carbon. So we have first quantified the blue carbon storage in the Ria Formosa lagoon in the different habitats we have with the focus on the Sosteranolti. And because it's a lagoon in which the tides and the flow velocity are main drivers of ecological processes, we quantified the blue lagoon, the carbon storage and also the sequestration rates along a gradient, hydrodynamical gradient. So we have one station which is more exposed to the ocean because here is the connection with the ocean, and then through this channel we reach the shelter location where the grain size is fine, it's totally matte, while here is more sandy. So we estimated the blue carbon, the different stations. As you can see, there is in Sosteranolti, there is a clear pattern in the carbon stocks, in the superficial sediment. So those locations that are more exposed to flow velocity has less carbon than those that are in shelter locations. So based on this data, we can create those ecological protection functions I was talking about, in which we relate one environmental, one the driver, the velocity, to the organic carbon stock. So this is the first ecological protection that we use. Okay, so this is the other ecological protection function we are using. Here we can see the nice correlation between the organic carbon in the sediment and the organic matter. So organic matter is much more simpler to determine in the sediment than the organic carbon. So with these correlations that are habitat specific, we can know the carbon stock in the area with just measuring the organic matter carbon. So we use these ecological protection functions in this case study that I'm going to present. So this is part of the Ria Formosa lagoon is a village called Fuseta. This is a fishing village, so fishermen needs to go out to the ocean to fish. And there are also here some touristic places, so there is a ferry connecting the village with the beaches. So in this area, there is a project to dredge this navigation channel, which is in pink, okay? And these are the deposit areas of the sand that they are going to extract. In the area, there are seagrasses. So the director of the natural park was aware of the presence of seagrasses in the area, so she called us to do this assessment of the losses of seagrass ecosystem services due to the project of the dredging. And so we went to the field and we did the assessment. We first did the mapping of the seagrasses with a drone and the ground truthing, and we took samples of the sediment and the biomass, so we can have, thanks to the ecological production functions we have for the area, we can estimate which is the blue carbon stock in all the area. We are using the INVEST model, the INVEST blue carbon model, which is a free model that you can use. It has been developed by the Natural Capital Project. And with this model, we create the maps of the carbon in the area. And as I said, we use these models to compare different scenarios. So in this case, we use three scenarios. Well, the first one is the original one, planning, which is the pink dashed line. And then we have three scenarios which, well, the first one is moving this 10 meters to the north. The second is reduce the length of the dredging channel to 10 meters. The original one is 20. And the last one is both together, okay? So basically, when we apply the models, we can see that there is a reduction in the directly impacted area of seagrasses in 60% in the last scenario, and a reduction in the losses of the blue carbon in 65%. So the models reveal clear direction of the impacts, and the promoter is in fact willing to adapt the project to avoid erosion of the carbon stock, and the project has not been yet done, so we are waiting for the movement. And the take-home messages, we see with this sample that the ecosystem service approach is a useful tool to inform coastal managers for better decisions, and is motivating in fact the support of the conservation of seagrasses in the Ria Formosa lagoon. And two key points are to have a research team with many different skills. We have a geographer and economician at the team, for example. And of course the willingness of the managers to do or to make the science-based decisions. So thank you very much.
Thank you very much. We have time for a question. Okay, Iron. My turn. Thank you, Lina.
Thank you, Carmen. And this was a fantastic presentation. I'm just curious how all this started. Who kind of started the idea of working with ecosystem services? Was it you, or was the managers, or was how?
Yeah, well, I came to Faro 2 years ago, so it was a project already developed by Professor Santos. He can tell you more about it. But I think it has been a long-term close relation with the managers, and also the fact, I think that for this kind of project to be successful, it's very important to have a figure, a researcher that has a very deep knowledge of the system and is well known in the area. So it's not just you came to a site and decide to do this kind of assessment. Maybe if there is nobody that knows you, maybe it's not working.
Thank you very much.